Hey everybody, going to go back to work on the Atlas lathe. This is the old Atlas 9-inch lathe, circa probably around 1934, as I think what we figured out. Possibly as early as 1932. Anyways, this is the first lathe that I acquired, and I actually acquired it around the same time as the Hendy. And this is the first lathe I actually got running and did anything on. And I haven't used this very much at all. I did just some simple turning and facing operations on it. The reason why I haven't really done any work with this is because the lead screw and support bracket, which is made out of this metal called Zamic, broke on this lathe, and it needs to be replaced. And those of you who've been following the Atlas series saw my attempts at trying to repair this. And those of you who have dealt with Zamic before, which if you want, you can Google that and you can find out why they call it Zamic. It has to do with the fact that it's an alloy of zinc, aluminum, and I don't know if it's magnesium. I forget exactly what's in it, but it's difficult to repair. And the design wasn't that great to begin with. It was actually designed as a sacrificial part. What was supposed to happen is if you had a crash with the lathe, what would happen is, instead of the gears shearing teeth, which the gears are also made of Zamic on this lathe, instead of destroying change gears, what was supposed to happen is this bracket is supposed to actually break away, and what would happen is that would allow the lead screw to literally just kind of unscrew itself from the other end and stop the drive. So that was the theory behind how that was supposed to work. And I think in later versions I think they kind of abandoned that whole idea and just beefed up this part because I think they were having a problem with it. I don't know if it was just because it could easily get hit on the end here and broken or what, but they changed the design, kind of beefed this up on later lathes. So my problem is I've got a part that I can't repair, so my plan is to make a new one. But what I'd like to do is I'd like to incorporate kind of the best of both worlds, kind of make an improvement on what was there, and at the same time I'd also like to try and keep a little bit of that safety net, so to speak, that was built into the part originally in here. So let me move the camera and show you what I'm looking at. Alright, so basically what we're looking at here is this is the end of the lead screw. I've got the carriage all the way up this end because essentially the carriage, with the carriage all the way up this end and the half nut engaged, I'm actually supporting this end of the lead screw. If I were to take the carriage and run it down near the headstock, this whole end of the lead screw would be unsupported, which obviously is not a good idea. So anyways, I've got it supported here, so this kind of keeps this captive in location where it needs to be, so I'll be able to make my measurements when I start to figure out exactly what size I'm going to make the various parts. So the first thing I did was I found an oil light bearing, or bushing. Yeah, I guess bearing would be a more correct term, to fit the shaft here. So that's my starting point as far as my design goes. That's about as far as I had gotten. So what I'm going to need to do is I'm going to need to make a bracket that's actually going to hold this and be able to be attached to the bed via the two threaded holes that are left behind. That originally, this originally actually acted as the bearing. You can see there's actually a hole here to oil it, and then the other part just screwed on there, and it kind of came out at an angle from the top here. So what we're going to do is we're going to have a plate that's going to drop down, that's going to be attached at the top. It's going to drop down here, and then it's going to have a block that's going to be attached to that, that's going to house this bearing. So it's going to be more kind of a 90-degree angle type thing, which is more in line with what the current design actually shows. I also have to deal with, there's actually a little bit of a lip, because there's a machined boss, so to speak, that the two tapped and threaded holes are located in. And then there's a little bit of a ridge there, and then there's the side of the bed. So in other words, since there was nothing in contact with this whole area here, they didn't bother making this all one machine surface. So if I just say take a piece of plate, steel, cut it to the dimensions, and bolt it on there, there actually would end up being a little space at the bottom here between the bed and the back of the plate. It's a very small space, but it'd be a space nonetheless. So I think what I'm going to want to do is I'm going to modify my plate to actually take that into account so that I don't end up with that little space there. So I think what I'm going to start with a rough sketch. Alright, so here's my drawing. Okay, so here's the lathe. Okay, so this is looking at the looking from the end, tailstock end, back up the other way. And on the side of the lathe body, or the bed, we've got this area right here that sticks out a little bit. That's got two holes in it that are tapped and threaded holes. Okay, and originally there were two screws that actually held on that original bracket. So what I'm going to do is I'm going to make this plate right here. Okay, and I'm going to screw that on to the side of the bed there. But there's a little bit of a notch right there. Not really a notch, but this sticks out just a little bit proud of the rest of the side of the bed. So I'm going to actually make my plate in a way so that it takes into account that difference right there. So that when I put this on, there'll be no space between here and here. Alright? Then what I'm going to do is I'm going to have a block shaped piece that's going to have a hole drilled through it, and the bearing that I just showed you is going to be pressed into that. Okay. On the backs, on the plate, I'm going to have a notch that I'm going to cut into the plate, and this block is going to sit in that notch. And then from the back side of the plate, I'm going to have a countersunk screw that's going to screw into the back of that. And I'm probably going to make that screw either be a brass screw or aluminum, something like, probably brass. And the theory is, what's going to happen is, in the event of a lathe crash, what's going to happen is this screw should shear. And so then the shear strength of this screw is going to dictate how much force can be exerted on the lead screw before it snaps. And hopefully that will be strong enough that it can do normal turning, but in the event of a crash, be weak enough to provide a little failure. So this is all theoretical, just kind of playing around here. And this is my front view. So here, these dotted lines represent the hole that bearing is going to sit in. So this pencil would be my lead screw that's coming through here like this. Okay, and this hole represents from the back side that screw coming through and attaching this block to the channel that I'm going to mill out in this this plate. Alright, so I'm going to get myself some dimensions here. I got to know what this little difference is right here so I can figure out, well, I want to know how thick I can make this plate. I want this plate to be thick enough so that I still can be able to mill a slot for this block piece to sit in and have a countersunk screw from the back screw into this. But I can't make the plate too thick, because then that means the block gets shorter and shorter, and at some point I won't have any place for the screw to go into before it actually goes through the bearing and hits the lead screw. So let's see what I got. Alright, so I started to get some dimensions here. So I know I'm going to be 1.9 inches wide on this plate, 2.3 inches long on this plate. This isn't as critical, as long as I'm long enough. I could have even made it longer, but we decided to go with 2.3 inches there. The little step out here, it turns out it's only 70 thousandths, so that's going to be easy enough. So the next question is, how thick am I going to make this plate? And really that's going to a big determining factor on how thick I can make this plate is going to have a lot to do with the size of this block. And the size of this block is going to be dictated by the position of the center line of the lead screw from the side here. So thinking I might want to try and determine my dimensions of this block and then work backwards to figure out exactly how thick I'm going to make this plate. Also, it would be nice if I could use a dimension, work something out so that I actually use something that already has a dimension. You know, in other words, if I use a piece of stock that's thick enough so that I don't have to mill it down, face it. Alright, so I cleaned up this top edge here. I had this rough cut on it, and so that gives me one surface to start as a reference surface, and from here I'm going to work off of this. Now on the last project I did, the CR250 part, I cleaned up this surface, then I inverted the part, put it in like this, and then took a cut off of here so that I figured I'd have two parallel surfaces. One of my viewers, I believe Dave, I actually forgot, I apologize for not recalling your name, but he suggested that I should be getting one good edge, referencing off of that good edge, and then doing it. If I understood him correctly, if I understood him correctly, my next cut should be this top 90 degrees to this. In other words, putting it in the vise like this, squaring it up in the vise, and then taking a cut. So I'm going to try that. I forgot how I did this last time. Of course, this bottom edge is buggered, so what I need to make sure that that's off the bottom of the vise. So I think what we're going to do is put it in here loose like that. Get something I can use for a square. Alright, so I just used one of these little precision angle blocks. And I put it in here. I kept this loose enough so I could manipulate it so that when I laid this in here, that it would be right up against the block. Well, that's close, but I think I'm going to indicate that because I just don't like, I don't know, I'm getting into that whole seat of the pants milling thing. Okay, so I was just about to break out the indicator. Take my end mill out. Put a collet in so I can put the indicator in the collet. Run the indicator over here, the last word with a finger on it, right? Clamp this in here, and then run the quill up and down, and have the indicator finger touching the side here, and watch for no deflection. Knowing that when I had no deflection, no change in the reading from here to here as the quill went up and down, that would indicate that the side here is perfectly parallel to the side of the quill, or the center line of the cutter. Then it occurred to me that I'm forgetting that this top edge of the vise right here and this top edge right here, this should all be perfectly square and perpendicular. So why can't I just put a 1, 2, 3 block on top of here? Stick this in here. Right. Hold it up against the 1, 2, 3 block. and clamp it in there. Now, maybe you guys could tell me if that's not kosher. I think it is. So, I'll have to let that rip, see what happens. Alright, so now I've got this side right here square to this side, and I just checked it using my machinist square, holding it up to the light, and it looks good. So now I want to cut, well, I guess I'm going to clean up this top edge right here. I know that was a climb cut, but I'm just going to, that was just kind of a rough cut. Now I'm going to take about 0.8 off on the return, which will be conventional milling, to clean it up. Now hopefully I didn't end up making this part too small. I mean, I started out with quite a bit of leeway. So now I want to mill that little relief on the back side of the block here that's going to account for this part where this bed is a little bit proud, where the screw holes are. So I know how deep I need to make this. I've already got that dimension, how deep I'm going to have to make that, but I didn't account for how far down this was. Forgot to take that measurement. And then when I went to take the measurement, I realized, well, I can't really get the calipers in there because of the way the bed sticks out on the top edge of the bed here, and then because of the way that the table's in the way. So I was thinking about it, and I said, well, why not just do it old school? So what I'm going to do is I'm going to hold the block up against the bottom edge, okay, of that area. There's actually a little bit of a bevel. It's not a sharp drop off, so I'm going to take that into account too. Alright, I'm going to hold that block on there like that, and I'm going to take the old inside calipers, and I'm going to set the inside calipers. That's actually a little too far. That feels right, good right there. And now I'll take my digital calipers and I'll just check what this dimension is on the outside, and that's what I'll use. I'm trying my best to do what is recommended in the old South Bend book, and actually another book I read talked about it too, and about how much of the right, this calls for a light touch. Heavy-handedness is not the way to go. It's all about the feel. Talks about how with experience how a lot of these guys gain that kind of feel. 839, let's round that up to 840 thousandths. If that slot's a little wider than it should be, I'm okay. If it's a little too narrow, then I got to go back and remill it. So that's going to be 840 thousandths. So I'm going to make a little separate diagram here, and we're going to call this 840 thousandths, and then this is going to be how deep? 70 thousandths deep. That's that dimension there. Alright, just occurred to me, shouldn't have shut that off. Because I can set these to 870 thousandths. And I was going to say I was just going to scribe this using the calipers. The only problem is these are my bargain Mitutoyos. They're missing the thumb screw. So on second thought, I'm not going to use these. I think what I'm going to do instead is, how about my nice sterrets? So, how do you use these? 700, 800. Oh, I almost said 870. 840. 840 thousandths. Lock that at 840 thousandths. Just for giggles. 841. Interesting. Just about to send these out for calibration. Alright, so I got this locked at 841 thousandths. And I'm going to take this and I'm going to scribe a line right there. I don't know if you can see it, but it is there. The light hits it just right, you can see it. I'm going to use the table on the mill and the dials to actually figure out how far over to go. But I just want that to be kind of my my idiot line, so to speak.